Okay, this is all about GNSS precise point positioning. It allows us to, anywhere in the entire world, set up a GNSS receiver. Now you can't do this with your iPhone GPS, but you do need a survey grade receiver. We can collect a few hours of data, email it off to a processor, and get precise coordinates back, usually within 24 hours or less. So the first thing you see on the screen here is kind of a map of Mongolia, and it shows 7 stations here, 4 of which are in China, 2 in Russia, and only 1 in Mongolia. Those are the stations that most of precise point positioning utilities will use. They are part of IGS, which is the International GPS System, which is worldwide operated by the US Navy. So basically that's showing you the stations that you would be using here in Mongolia, even though you don't ever need to go anywhere near them, but those are the ones that are going to be used. What you need to do, find the location of the SD card. And now I pre-configured this receiver to collect data at a 1-second interval. Now for precise point positioning, you don't really need 1-second data. 30-second data is more than sufficient. It's more important to have a long duration than it is to have more data. It's more important to have 4 hours than it is to have 1-second data. 4 hours of 30-second data is much better than a half an hour of 1-second data. What I configured that receiver to collect 1-second data, and now we're going to use a utility after, and we're going to pull 30-second data out of it to send off, because we don't want this giant file because it takes too long to email it and get it back. And I would recommend 30-second data for precise point positioning. So basically, all you have to do with one of these receivers, it is pre-configured to collect 1-second data the minute you turn it on. So all you need to do is set it on a tripod, but what you have to do is make a note of the height of the antenna, which is the height of the rubber ring around the top here. You would have to put some kind of a marker on the ground, set your tripod over it, set this on, measure the height, and record it. Because what you want to know is the precise coordinates of that point on the ground and the elevation. It says here, most PPP services require at least 2 hours of data to process, but 4 to 12 hours will yield much better results. Now in Mongolia, because you don't have a lot of courier stations close by, they are really a long ways away, they're countries away, you should look at the 4 to 12 hour thing. Now I would say use 4 as an absolute minimum. Now the way we're going to do it, if we're doing any kind of RTK work, we're going to set up the base and then we're going to work all day, which is probably going to be 4 hours anyway. So as long as we don't interrupt the base, we're going to have our 4 hours of data or more. So the bottom line is I would recommend an absolute minimum of 4 hours in order to get a reasonable position, and even 4 hours isn't going to give you I would expect your position in 4 hours here in Mongolia to be within probably 10 centimeters horizontally and 15 vertically. That's probably as good as you're going to get with 4 hours. Typically, what I would do in Canada, if I was like a typical job for me would be to go run control for a mine site or whatever, and I'll go and set the receiver up the night before and let it run all night, and then in the morning just come and turn the transmitter on to transmit corrections, and then let it run the rest of the day. And I usually end up with probably at least 16 hours of data, and that will give me a really precise position. anyway, it's all dependent on how long you can leave that receiver there, how well your position's gonna be. And all you gotta do is make sure the SD card is in here, turn the receiver on, and when you do, you'll see that this little yellow light on the far right will start blinking like you saw this morning. That's this light right here, and that just means that it's logging data. That really is all there is to it. Well, it's not all there is to it till you get to the processing part. I have a utility called Rhinex Desktop here, and what you do with Rhinex Desktop is you load your binary file, fire up Rhinex Desktop, which is a Hemisphere utility. You load your binary file and you go through. Basically, you don't have to really change any one of these settings really. And you can go in here and you can set your antenna height that you've recorded in your little book. You can record in here, and if you go in here and it'll say binary data rate, 1 second, you can change that to 30, and what it'll do is it will extract 30-second data out of the 1 second file. Okay, because you don't need 1 second data for PPP. In actual fact, 30-second data probably works better. The theory behind that is the satellites are 1,100 miles up in the air, 20,000 kilometers. So in 1 second, they're not going to travel very far. So you're going to get a very, very narrow triangle out of that. In 30 seconds, it travels farther, and you will get a wider triangle. So the mathematics of the wider triangle are more reliable. And that's the reason that 30-second data is better. So basically all you do in here is change this to 30 seconds. And this will pull your 30-second data out of there, and it will convert it to Rhinex. And Rhinex is a receiver independent exchange format that all of these precise point positioning people understand. Some of them will actually take native files. In other words, you could send them a Hemisphere file directly or a Trimble file directly. Some of them will, and they'll convert it or extract data out of it. There are many different online PPP services available. Both their input and output requirements are very similar, as well as their results. For the purpose of this training, we will use the US OPUS PPP. And in the US, OPUS stands for Online Positioning User Service. And we'll use the University of New Brunswick GAPS PPP system, since they are available worldwide and have very simple input procedures and good reporting. You may choose any other service if it is better suited to your needs. I will see if I can, connect to the US one here, if they haven't changed their address since I did that PowerPoint. So this is what Online Positioning User Service looks like. And it says here, choose a file. So right here, you can just go and pick your file out of your folder and say OK. And so in here, you can also select an antenna, but normally when you pick your file, I believe this will populate this, but there's a gazillion antennas in here, and you are going to want Hemisphere in here somewhere. No. Gee, just a minute. Hemisphere, here you are. Okay. Hemisphere 320. You would select that because that's the instrument you get. Okay. You would select that, your antenna, and this is where you put in the height that you've measured. Then you put your email address in here, and that's where you want them to send you your data. And in here, there are some options to customize your solution. Most of those have to do with the US state plane coordinate system. They use I'm not sure that any of these would be appropriate. See, they're all different states. I don't think, I would say let OPUS choose here. And your format here is going to be, that's the format of your report. Now you can get a standard report, which is probably the only thing you would ever want. You can get an extended report, which gives you a whole bunch of graphs about how many satellites and where they were and standard deviations up the yin-yang, and none of that's going to mean diddly squat to you. And you can put project identifier here. You could say SESMIM 001, or whatever you want to call it. You can then you can set a profile, which is parameters that you're going to use every time you use this, and it'll just pick them up when you put your email in. Share my solution. That's something in the US that they use amongst the surveyors there, I guess, so that if you do one and you say you want to share it, I can go here and pick up coordinates for your base station. All I got to do is go to your base station and set up, and away I go. Upload to rapid static is something you will never use, because it's 15 minutes to 2 hours duration of your file. A 2-hour file in Mongolia is not going to give you a very good answer. You're going to need to upload to conventional static, and I would recommend at least 4 hours of data. Because your base stations are so far away, in order to get a decent solution, you're going to have lots of data. Get lots of duration, not necessarily lots of data. So, and when you're done, you just hit upload to static, and away it goes. Wait for your email answer to come back. And every one of these services operate kind of the same way. Fill in your information, email address, your antenna height. Because when they talk about antenna, they're talking about the GPS antenna that's built into that receiver, not the radio antenna. So basically all you do is wait until you get your email back. Now we can look at the Australian one here. Okay, this is the Australian one, which is probably even simpler, and it may be the simplest one to use. You just choose your file. It'll just take you out and pick a file out of your directory, your antenna height and your antenna type, and it's basically going to give you the same list of stuff that you had before with the other one. Hemisphere 320, and antenna height and your email address, and send it in. Submit RINEX using upload. You can even do it via FTP. And that's the Australian one. So you can see how simple that is. And I would almost be tempted to use the Australian one here in Mongolia, simply because I know that they have done some work. They may have some additional base stations that they would use that you wouldn't get by using the US one. Or this is from the University of New Brunswick. They have one called GAPS. It works well. Choose a file, and you pick here GPS, Galileo, Beidou. These are 3 different satellite systems, and what they want here is your starting. Oh yeah, if you just leave them at 0, it will pick the coordinates out of your RINEX file. So you can leave these at 0. The way GPS solution works is it starts with an approximate position, and normally that position has to be within about 10 meters. If it isn't within 10 meters, it takes a long while, and it just keeps going through iteration after iteration, and it just keeps slowly converging to give you a more precise solution. So what they're saying here is if you get better coordinates, stick them in here and the processing will be quicker. And they've got an elevation cutoff angle here, which the other ones didn't have. You can change this to whatever you want. The University of New Brunswick one will do kinematic. Now what kinematic is what I was telling you about. You can stick an antenna on the roof of your car and drive up and down the streets in UB, and you can collect 1 second data, and you can send that data, and they will send you back coordinates of your entire path. So, and you put your email in there and tell them you're not a robot, and away you go. So you can see they're all very, very similar. I mean, there's not much to it. Now, in the next slide here, you'll see here, this is the Australian positioning system, a relatively painless method of data processing, and it uses a German Bernese engine. It's free. It produces ITRF 208 coordinates. It uses EGM 208 elevation. It will do very precise coordinates. If you want to wait 3 days or more, they update the satellite orbit information, which will give you a more precise solution. Now, the difference between using what they call the broadcast ephemeris. Ephemeris is nothing more than a file that predicts the location of all these satellites. Now, if you wait 3 days, they will give you a more precise one. The difference in the actual answer you're going to get is going to be millimeters. Unless precision is very important to you, it's usually not worth your while to wait the 3 days and then download. And I can't see you guys having any need for that kind of precision for the stuff you're going to be doing. This is an Australian positioning system result that they send you, and it tells you all different satellites that different base stations that they've used. Now this, I recognize some of them. This is Albert Head and Vancouver Island. This is Penticton. Obviously this is a Canadian one that I've done. Williams Lake. You can do geodetic GRS 80 ellipsoid, which is what WGS 84 is based on. Giving you all these coordinates. What they do with ITRF coordinates, they publish velocities, and they're saying 208, and really to be extremely precise, you have to apply the velocities to the answer based on the number of years between 2008 and 2017. So you got 9 years, so if it creeps by a millimeter a year, it changes it by 9 millimeters. So the difference is very tiny. On the next screen, this is the Canadian output, and basically what it gives you here is right here, down at the very bottom on the right hand side, you get your final UTM, zone 12, northings, eastings, and all that stuff. But if you want to look at accuracy, you got to look up into here, 95% sigma here, and this is 7 millimeters, and that's 15 millimeters. But the amount of data here was 6 hours and 55 minutes, so it's 7 hours worth of data. But that's how good that position is. 7 millimeters and 15 millimeters, and 3 millimeters in height. But this is in Canada where there are more base stations, and there's 7 hours worth of data. So it's a very good example. For Canada, you would probably have to leave a receiver twice that long in Mongolia to get the same results. But anyway, that's typical output from the Canadian one. And now it says we'll work through an S320 bin file online from start to finish to show you just how simple it is to establish reliable control stations. Well, we won't do that today, but what we'll do is we will take the static file that we collect tomorrow, and we'll fire it through. It probably isn't going to give us a very good answer because we're not going to have 4 or 8 hours worth of data, but we'll get enough data that we'll be able to send it anyway. That is how you can establish a reasonable base station location from anywhere in the world.